The next problems were meant for a calculator. For part of it, we'll be just doing it by hand and talking about how it could be done on the calculator. But we have an object moving along a curve in an xy plane that has a position x of t comma y of t at time t, with dx dt equals sine of t cubed and dy dt equals cosine of t squared. At time t equals 2, the object is at the position 7, 4. So first, we want the equation of the tangent line to the curve at the point where t equals 2. So, one of the reasons why this was a calculator problem is that you can't actually give a value for sine of 2 cubed or cosine of 2 squared off of the unit circle, but that's okay. We're going to keep the answers exact. If you want decimals, then you could just plug them into the calculator. But to get the tangent line, we need a point and a slope. At t equals 2, we have a point. We know that our point is 7, 4. To get our slope, we know that dy dx equals dy dt divided by dx dt. Our dy dt was given to us as cosine of t squared, and our dx dt is sine of t cubed. And we want this when t equals 2. So I'm very simply going to evaluate this at t equals 2. So our slope will equal cosine of 4, which we can't get an exact value from the unit circle. This is exact, over sine of 8. So if you want to get the decimal again, plug it into your calculator. If not, just use this. Our tangent line is y equals, and my slope is cosine of 4 over sine of 8. My point has been shifted 7 to the right and 4 up. So my equation is x minus 7 plus 4. And that is it. To find the speed of the vector at t equals 2, we know that speed is the magnitude of the velocity vector. So when we're doing magnitude, we're asking for the length. We know that our velocity vector has an x component and a y component. So when we want the length, we'll use the Pythagorean theorem. So to find the speed, we're going to do the square root of our dx dt squared and our dy dt squared. So our dx dt is cosine of t squared plus then our dy dt is, I just switched that, this is dy dt, and then we have dx dt is sine of t cubed squared. Since addition is commutative, it doesn't really matter. We want this at t equals 2. So I'm very simply going to plug 2 into the t values here. We have the square root of cosine of 4 squared plus sine of 8 squared. And whatever this is the speed of the vector at t equals 2.